Alright, so let's go through this 2022 O-Level Pure Physics Paper 2 question 1. So this is actually a warm-up question for the start of the paper 2. Okay, so part A, state what is meant by velocity. Okay, so this is just the definition. You just need to say that velocity is the rate of change of displacement. Yeah, so as long as you say rate of change of displacement, the 1 mark is yours. Okay, part B, same thing. Velocity is a vector quantity. Underline all the quantities that are also vector. So vector means you must have magnitude and direction. Right? Okay, so same. So the very first will be acceleration. Displacement is also a vector. Okay, energy is not a vector. So energy is a scalar. So this is a scalar. Power is also a scalar. Weight is a vector. Work is a scalar. So there are only three vector quantities here. So this is part B. Okay, so let's go on to part C, where we have this velocity time graph of a small firework fired vertically upward from the ground. So you can see this velocity time graph. So the firework runs out of fuel. So at point B, before when moving with a velocity of 60 meters per second. Okay, so what is going on for these firework guys? Okay, so very first part is where the rocket or the firework still have fuel. So it's actually accelerating. So this is with fuel. Okay, so at point B, you run out of fuel. So when you run out of fuel, you cannot accelerate anymore. So you just decrease in speed. So decrease in speed, but you are still rising up. So you are still rising up. Right? So, but this second part is without fuel. Alright, then after that, at point C, right, you actually, at 10 seconds, you actually have a velocity of 0, means that you reach a maximum point. Then after that, you go to CD, right? So CD is where you actually fall back to the ground. Alright, okay, so part I draw a line to join each region on the graph to the description of the motion of the firework in that region. Okay, so let's take a look at AB. So region of graph AB is actually your velocity is increasing at a constant rate, right? Okay, so let's see what is given to us. So motion of firework. So number 1 is moving downward and accelerating downward. This is wrong because we know that AB you're actually moving upward, right? So this AB is moving up. Alright, so this is wrong. Okay, number 2, moving downward and accelerating upward. This is even wrong. Okay, parts number C, moving upward and accelerating downward. This is also wrong. So the last one will be moving upward and accelerating upward. This is correct because AB actually you have some fuel. So this fuel will cause you to accelerate upward. Right? So this is accelerate upward. So AB is, you just need to draw this line. A bit like kindergarten like that. Okay, for BC, BC is where I run out of fuel. So my speed start to decrease at a constant rate. So let's see what we have. Okay, so BC, right? So number 1, moving downward and accelerating downward. So this is not moving downward. For BC, you are still moving upward. So you are moving up. Right? So number 2, moving downward and accelerating upward are wrong. So number 3, moving upward, accelerating downward. This is correct because you don't have any fuel left. So the rocket is actually accelerating downward. So this is BC. Another way to see is very simple. So first thing, so accelerating downwards. Okay, other way to see what is the direction of acceleration. If you are moving faster, or you're moving faster and faster, means that the velocity and the acceleration must be in the same direction, right? So for example, let's just say I draw a car. You're moving here, right? So if you want your car to accelerate, means you want your car to speed up, your acceleration must also be in the same direction to increase its velocity. Okay, for BC, which is you're moving upward, but you can see that the velocity actually decreases, means that you are decelerating, right? So the acceleration must be in the opposite direction. So for example, if same thing for BC, I draw a car, you're moving here, but you're actually slowing down, means that your acceleration must be in the opposite direction. So BC should be moving upward and accelerating downward. Okay, last but not least, CD. So what is going on in CD? So CD actually, okay, you at point C you reach the maximum height. Then after that you reach the maximum height. The only motion you need to do is actually to fall down, right? So CD you are falling down. So CD you are moving downward, right? So you're moving downward, and of course you are accelerating downward also, right? So the answer will be the first one, right? So these are all the three lines in order to get the 2 credits. Okay, so part 2, same thing. State the time at which the firework reaches the maximum point. So this is where your velocity is equal to 0 meter per second. So from the graph, right, you can actually see is point C, which is 10 seconds. Alright, so the last part of the question, using figure 1.1, calculate what is the maximum height reached by the firework. For maximum height, if you look at the graph right here, the maximum height is actually the area of this triangle, okay, until you reach the maximum point, right? Then after that, CD, the triangle of CD is irrelevant because CD is beginning to fall already. So you just need to calculate the area of this triangle. So same thing is half times base, which is 10, right, times height, right, so it's 60. So 600 divided by 2, 300 meter. So that is the maximum height that you will reach for the firework. So 300 meter. Alright, so that's it for this warm-up 2022 O-level